Welcome to Study Loop.
Okay, so this is a diagram of a pinhole camera when we have two objects. So we're considering the center of the objects, and from there, this is the pinhole. So the image is formed at the film or the back of the um, pinhole. So we see that if we take the center, they're forming the images over here. And if we consider the distance between the centers of the images, and we call it h, and the distance from hole to the screen is L2, and the distance from the hole to the image objects is L1, and the distance between the objects is h. Now we already know all the values for h, L1 and L2, and from there we can actually find out the distance between the objects, because we have a triangle over here and we have another triangle over here, so we can actually use the ratio rule here. Now one thing we should remember here is we see that L1 is actually 50 times larger than h, but in the image it's not scaled properly, so we need so that's something to consider. Anyway, so if we consider the base over height for both of the triangles, we get something like the following. So we'll have base, which is h for the bigger triangle, over height, which is L1, and that should be equal to the base h over the height L2. Right. So from here we can actually find out the separation between the images, which is equal to h, and we can write h as big H times L2 over L1. And let's plug in the numbers here and see what we get as the separation. So L2 is 7.0 and L1 is 100. So from here we get the separation as 0.14 centimeters or 1.4 millimeter. Right. So now we know the separation. So we need to now compute that whether they will be resolved or we can see separate images or not. So to do so, if we actually take one of the objects, so let's consider this triangle, and I drew this one over here. So D is basically the diameter of the pinhole. So D is the diameter of the pinhole, and big D is the diameter of the image. So we can conclude that if the diameter of the image is lesser or equal to the distance between the images, then we can see the images clearly. We can actually see both of the images clearly, so there will be no overlap between them. So let's see if we can do that using this diagram. So now we know that from here, from pinhole to the object, the distance is L1, and from pinhole to the image, the distance is L2. Right, so now we can actually see two different triangles again, and we can use the base over height formula to find out our diameter, because this guy is given. So small d is given as 1.0 millimeter, and these two guys are given. So let's actually use the ratio rule here. So it's going to be d over L1, which is equal to big D over this whole distance, which is L1 plus L2. L1 plus L2. Right, so from here we'll solve for big D. So big D is going to be little d times L1 plus L2 divided by L1. So let's put the numbers here. So it's going to be 1 millimeter. Then we have 100 centimeters plus 7 centimeters divided by L1 is 100 centimeter. So that gives us a value of 1.07 millimeter. So now we see that this number, or the diameter of the images, so this will be same for both of the images. So we see that the diameter of the images is lesser than the separation between the images. So hence we can conclude that we can see two images separately. Thank you.